Hi friends, welcome to my channel. Let's have a look at problem 56, merge intervals. So actually this problem represents a class of problems that can be cast into interval merge. So in this video, we're going to share a line of thought based on sorting and linear scan. So as we promised previously, we're going to summarize these kinds of problems in the playlist. So this can be regarded as one of the videos. So you're also welcome to check out the follow-up videos and other videos in the playlist. In this video, first I'll read through the problem statement, and then we explain the line of thought or methods, and then we share the code. First, let's look at the problem statement. Given an array of intervals, where intervals is represented by a list called start and end. So merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So this is the short statement of this problem. So here are two examples. So let's first look at example 2. So in example 2, so there are two intervals, so 1, 4 and 4, 5. Because 4 and 4 are the same, so these two intervals can be connected together. So we get 1, 5, right? So this is the output. So notice that in this problem, the output is a list of intervals or list of lists, right? So in example 1, so we see that 1, 3 and 2, 6 have overlap. So the union of the two intervals is 1, 6, right? The corresponding to this one. And then 8 and 10 has no overlap with 1, 6, and also it has no overlap with 15 and 18. So we add 8 and 10 to the list. And then we look at 15 and 18, right? So this interval has no overlap with the previous intervals. So we append this also to the output. So overall, the output consists of three intervals: 1, 6, 8, 10, and 15 and 18. Notice that example 1 is very special in the sense that so the intervals are already in sorted order according to the start of the intervals. You know, this is the 1, this is 2, this is 8, this is 15, right? But however, in general, this is not guaranteed, or this is not assumed, right? So these are the two examples. So let's also look at the constraints. The first constraint is about the interval size. So its length is bounded below by 1, which tells us that this list is not empty. And its length is bounded above by 10 to the power 4, right? This is a decent large number, which actually defines the problem size. So each element in the intervals list is a representation of interval. In other words, it's a length 2 list. So the third one is on the start and end range, right? So this bounded below by 0 and bounded above by 10 to the power 4. So this restricts the intervals to the right of the origin. So actually this is not very essential, right, for this method we are going to explain. So with that said, we are ready to do the analysis. So actually, if we realize the speciality of example 1, so then the problem can be solved very easily or very elegantly. So here we are going to use sort and linear scan. So the main points are the following. First, so we want to check if the intervals have overlap or not. So we need to have a reference point. For this, we are going to use sort. So in here item 1, so we use sort to make sure the later intervals have larger starts. So this provides us reference for check overlap. So this is the first item here, or first point. The second point is that after sorting, So to check overlap, we just need to compare the start of the current interval. Let's call it a current start, current S. Compare that with the end of the previous interval. Let's call it previous E, right? So then this just have two cases. First, if the current start is to the left, in other words, less than or equal to the end of the previous interval, then there is overlap. Otherwise, if the current start is strictly larger than the end of the previous interval, then there's no overlap. Then we just need to do whatever we need to do in this kind of problems, or problems that can be transformed into interval merge type. So with that said, we are basically ready to write the code. So I would suggest that you follow up the playlist and the other videos in here. So with that said, we are ready to write the code. So first, let me do the sort. So this is an important step. So basically, we need to sort according to the first, the start of the intervals. So here, let's do the sort in place sort. So here we're going to pass a function. Let's use a lambda function. So we're going to sort according to this one, right? So if you like, you can write a secondary key. So you can sort it like this, or you put a negative sign, sort it reversely according to the end. That's not matter much. So this is the first preparation step. So next, so we're going to prepare the return. So for this, I'm going to initialize the result like this. The interval is 0, right? And then what we are going to do is to do a linear scan or traverse the interval list. So basically, I'm going to, for I in range, so we can use length intervals. And then first, let's get the current start and the current end. So current start, current end. So it's nothing but intervals I, right? And then we want to compare the relation of this current interval with the previous intervals. So if there are overlap, we're going to merge. Otherwise, we just append to the result. So this is actually very easy. So we just need to compare the current start with the previous end, right? So previous end is nothing but, so let's see, previous end. So previous end, the current S. So previous end is nothing but interval, but result -1 in the tail, and then the second element, right? So, and then let's consider this. If the current start is less than or equal to, so notice this, less than or equal to, we need to consider the equal case being overlapped. So if this is the case, in other words, there is overlap, then we're going to do this. So previous S, previous end. So we're going to do result pop. And then we want to merge this one with the current interval. So this is actually easy. So the merge result is nothing but this one, previous S, because we have doing sorting. So previous S is always less than or equal to current S, right? So then what we want to do is that we choose the large of the end, that is max, previous end, and current end, right? So this is the one case, right? Otherwise, so there's no overlap with the last element in the result, and then we just need to do result append the current interval, right? So that is actually intervals I, or you can write current S and current E. So this is the overall procedure. So after we finish the linear scan, so we just need to return the state of the result variable. So up to now, we finished the coding for this problem. So I guess it's better to first do a check. Yeah, it passes the first example. Now let's look at the second example. So this one is actually a simple one. So yeah, it passes this example. So now let's look at the generic case check. Yeah, it passes all the generic cases. So with that said, that's about it for this specific problem. As we mentioned, we're going to do a number of such problems. So now let me explain again the general principle. So here the principle is like that. So we need first to do sort. So once we do the sort, so we actually can compare the current interval. Let's call it S and E. And then the previous one, let's call it moving S and moving E. Then we need to distinguish two cases, two big cases. The first case is that the moving E here is less than S, right? So if it's less than S, so there's no interval merge. In other words, there's no overlap. Then we update, right? The moving S will be the current S, and then the moving E will be the current E, right? We move to the right. You can think of like this. The second case is that the moving E is actually greater than or equal to S, right? So you can think S is less than or equal to moving E. Maybe it's better, right? So in this case, either we are here, right, or even here. So one thing that is sure is that this S, because we have done sorting, is always no less than moving S. But the E, so if we want to do the interval merge, so we need to choose the larger E. So in this case, the interval merge happens, and then the updating is like this. The moving S will be the current be the smaller one, right? Because we want to use larger interval to cover the small intervals. And then the moving E will be the larger of the moving E and the capital E, right? So that's the overall principle. Actually, this is also exactly what we used in this coding. So let's review the process again and then do another problem in the follow-up video. So here we first do sort so that we can have some reference for comparison. And then we compare the current interval start with the previous interval end. If the current start is less than or equal to previous end, there's overlap. Otherwise, there's no overlap. Then, according to the problem requirement, then we do whatever we need to do into this kind of problem, or problems that can be transformed to interval merge. So with that said, I guess that's about it for this video. So in the next video, I guess we are going to do problem 57, if I'm right. So with that said, I guess thank you.